so let's take a look at this. It says learning targets. Write the equation of the circle given the center and a point on the circle. Write the equation of the circle using the graph of the circle. So recall the equation of a circle with a center at 3, -4, and a radius 5 is written as x minus 3 squared plus y, in this case, plus 4 squared equals 5 squared, which is 25. Now, if we graph this, we would have, again, the center at 3, -4. So 1, 2, 3. So there's my center. And then from here, I count up 5. 1, 2, 3, 4, 5. And I go to the right and left 5. I think that's 3 to 8. And then this is 3, 4, 5. And then I'm going to go down from the center. 1, 2, 3, 4, 5. So here's my circle. All right. How can we write the equation of a circle if we are given the center but not the radius? In this case, you will use a point on the circle. So if we were given just the center and nothing else, we could use any of these points that I just drew in here. So what are the steps for this? Well, in this case, the first one is plug points into the circle equation. To find r, which is, again, remember, our radius. And then we write the equation using the center and r. All right, questions on that? Anybody still writing this down? Okay. All right, let's go to example 1. So this is the equation of a circle with center r -2, or center at -2, 4 that contains the point -5, 1. All right, so again, remember, our circle equation is x minus h squared plus x minus k, or I'm sorry, y minus k squared equals r squared. So this is our center, this is our h, this is our k. This gets substituted in for x and y to solve for r. So we're going to have here -5 minus or plus 2 squared plus 1 minus 4 squared, and we're going to say that equals r squared. This leaves me with -3 squared plus, looks like another -3 squared. So this will be 9 plus 9 equals r squared. So that would be 18. So that's our step one. Our step two is write the equation. So this will be x plus 2 squared plus y minus 4 squared equals 18. Now I know there's a graph here. And if we wanted to graph it, we would start at our center, which is negative 2, 4. And then we would take the square root of 18. Someone tell me, what is the square root of 18? This one you're going to need a calculator for, because I don't even know this one off the top of my head. So about what is it? Yeah, so about 4.2-ish, right? Okay, so about 4.2. Now, one thing we do know is that we have a point, negative 5, 1. So here's negative 5 up 1. This acts as our radius, which is 4.42. Wow. That is not going how I anticipated. So about 4.2. Okay, so if we wanted to, we would go another 4.2 this way. Again, I don't know where that lands, but we'd have our circle. We'd still do the same thing. We'd still go 4.2 this way, 4.2 that way. Okay, it's just not as nice to graph because of the fact that it's 4.2. All right, let's move on to example 2. Any questions on this? All right, so we're going to write the equation of the circle again with the center at negative 2, 3. That contains 0.03. So this is our h, this is our k, this is our x, this is our y. So we're going to have 0 plus 2 squared plus 3 minus 3 squared, which equals r squared. This leaves us with 2 squared. This becomes 0 squared. So this is just 2 squared, which equals r squared. So r squared is equal to 4. So that completes our step 1. Now our step 2 is just to write the equation. So in this case, we're going to have x plus 2 squared plus y minus 3 squared equals 4. Are you guys okay over there? What's wrong? Ouch. If you want to, I'll let you see my note sheet once we're done. Okay. I want you guys to try the you try it 1 and 2, please. All right. Anybody still working on these two? All right, taking a look at the first one. Someone tell me, what is the equation for this one? Who's got it? Should I go to delta? Luis, what'd you get? Say that again. Just -1? You're supposed to get an equation. Whitney, what'd you get? Oh, I was just asking for the equation, but you're going through it. That's fine. Squared plus, what'd you get here? Very good. Okay, so in the end, what was r squared? Tell me that. 29. Very good. So now, who would like to give me the equation? Go ahead. Very good. There it is. Questions on one? All right, let's take a look at two. Who's got the equation for two? What's the final equation? Iana, what'd you get? Perfect. Questions on that? Everybody need to see this. Okay. Let's scroll down to the next part. It says to write the equation of a circle using the graph of the circle. All right, so first thing is you locate the center and use opposite signs in the equation. All right, step 2 is draw the radius. Okay. Count the length. And square when putting into the equation. So now what does this mean? Well, we're going to go over that in just a minute, but right now just write down the directions. Anybody still writing? Okay, so let's take a look. It says, what is the equation of this circle? Okay, so the first thing I would do is this. I would find, just kind of that longest point, kind of like this. And I would do it side, but I would also do it up and down. That helps us identify the center, which in this case looks like it's 3, 3. Okay, so our center is 3, 3. The next thing we need is we just need from the center to count to the end of the circle. So we're going to count 1, 2, 3, 4. So our radius is 4. Now the equation is going to be x minus 3 squared plus y minus 3 squared equals, this is going to be 4, but we're going to have to square it on the end, right? Because it's always r squared. So that'll be 16. So that's kind of what the directions were saying up there, but just, the visual helps, right? Why don't you guys try the second one on your own real quick? Who's still working on this? Number 2. All right, anyone want to volunteer their equation? No? Bueller? Anybody? Okay. Let's see. Who does delta math decide? Rebecca. What do we get? Oh, sorry. You just said -1 here. Oops. Equals, what'd you say, 9? Nice job. Anybody need to see this? Questions? Comments? Concerns? Snyder marks? Delta math. It's assigned. No reason you can't get it done before you leave here today. Okie dokie artichokes. Questions? I said artichokes. All right, those who watch at home, have a great day.